This is a Jiku Power1D tutorial. This tutorial is about the sample size analysis mode in Jiku Power1D. If you haven't already watched the Power Mode tutorial, please watch it before this one. The goal of sample size analysis is to estimate the sample size, or sample sizes, that are necessary to detect an effect with a certain power. Let's start with the one sample design and set the default model. In the Analysis panel, let's select Sample Size Mode. You'll see that there is one more parameter at the top, Power. This is statistical power and is the target power for the analysis. Statistical power is the probability that a test will identify a true effect in a large number of experiments. The target power is usually 0.8 or 80% by convention. The sample size selection is also different than in Power Mode. In Power Mode, for the one sample design, there's just one parameter, n. In Sample Size Mode, there are new parameters, n initial, n final, and step size. Jiku Power1D will incrementally run power analysis for different sample sizes, starting with n initial, finishing with n final, and incrementing in sample sizes that are specified by this step size parameter. Let's press run to see what happens. You'll see that Jiku Power1D conducts power analyses sequentially, plotting the omnibus power for each of the separate analyses. Here 5 analyses were run, one starting at n initial of 8, then one for n equals 9, one for n equals 10, one for n equals 11, and then a final one for n equals 12. So this horizontal axis represents the sample size. The vertical axis represents power, and the target power is highlighted by a horizontal red line. If the analysis is sufficiently powerful, it will cross this red line. In this case, we have not crossed the red line, which means that the sample size is too small to reach the target power. So let's increase these parameters, increase the sample size, so that we achieve the target power. Let's set the initial value to 14, the final value to 20, and a step size of 2, and press run again. You'll see now that the analyses are more powerful than before, and that we now cross the target power line. These results suggest that a sample size of 18 is needed to achieve a power of 0.8. Let's fine-tune that. Just to confirm. We can even increase the number of iterations if we want to achieve slightly better, more numerically stable results. These new results, with a slightly higher iterations value, suggest that a sample size of 18 is required to achieve the target value of 0.8 power. Note that sample size mode is the inverse of power mode. In power mode, you set the sample size and calculate power. In sample size mode, you set the target power and then search for the sample size that meets that power. In other power software packages like G-Power, sample sizes can be calculated almost instantaneously because the data are simple, usually just simple scalar data. So mathematical equations can be used for this inverse probability calculation. Jiku Power1D instead calculates power for complex 1D data with arbitrary effect geometry and arbitrary noise, and no mathematical equations exist for these conditions. Jiku Power1D therefore adopts this incremental power calculation as a clearer way of indicating the relation between sample size and power.